Good evening. The topic of the presentation is LL1 Parser for SPCC Internal Assessment 2, presented by myself Arnab, Heeral Dedhia, Arvind Sridhar and Doshi. So the basic points we are going to discuss throughout the presentation are abstract, LL1 Grammars, first and follow, parsing table, output, algorithm and implementation. So let's start is, what is an LL1 Parser? The first L represents that the scanning of the input will be done from left to right manner. Second L shows that in this parsing technique, we are going to use leftmost derivation tree. The 1 in LL1 parser represents the number of look ahead, means how many symbols are you going to see when you want to make a decision. Now the abstract. An LL1 parser, that is left to right and leftmost derivation, is a top-down parser without backtracking for a subset of context-free languages. It passes the input from left to right, performing leftmost derivation of the sentence. LL grammars, particularly LL1 grammars, are of great practical interest, as parsers for these grammars are easily to construct, and many computer languages are designed to be LL1 for this only reason. LL grammars can also be parsed by recursive descent parsers. Now, LL1 grammars. A language is said to be LL1 if it can be generated by a LL1 grammar. It can be shown that LL1 grammars are non-ambiguous and not left recursive. So what does ambiguous means? If a language has more than one left derivative tree or more than one right derivative tree or more than one parsing tree, the language is called, the language of the grammar is known as ambiguous. Now, LL1 grammar, the basic flow of LL1 parsers are, there are what most LL1 grammars, there is parsing table, there is input output buffer and there is a stack. The basic function involving LL1 grammars are, basically there are basic two functions, that is the first function and the follow function, which will be explained in the later slides. Thank you.
First and follow. These sets are used by an algorithm which produces an left to right left derivation parsers, also known as LL parsers, from a grammar. There's also a number of other algorithms which analyze grammars, but most importantly we run into them while studying about top-down parser. Parsing is a very small activity of producing a compiler. The first and follow sets have very little to do with compiler design, but they are useful in understanding how a particular algorithm works. First and follow is a two-step process. Firstly, we start off with finding first for a given grammar, and then using that given found first, we proceed to find follow for the given thing. So why do we need first and what does it do? First of a non-terminal would refer to the first character of strings that can be derived starting from that non-terminal. The first of a terminal would be the terminal itself. The last point is something that we need to take care of. So there are certain rules given to find the first set of a given grammar. Coming to the second part, why do we need follow and what does it do? Follow of any non-terminal A refers to the first of the non-terminal or the terminal that immediately comes after A in the derivation rules. To understand it in a better way, let's consider an example here. In the given example, we see that there are 6 different productions given. So start off with, we start with G. To find the first of G, we go and see what is the first terminal that appears. To find that, we need to go to E. Then E will refer to TK. So we have to find the first of T. We go to T and find the first of F. When we go to F, we see that there is an open brace. So that open brace is the first of G. So we have an open brace here, and it can also be A. So we have two first of G, that is open brace and A. So coming to the second one, to find the first of E, we go to T, and from T we go to F. From F we have two things, open brace and A. So we copy that. First of K will refer to plus. The plus given, that is the first terminal which can appear. So we put that and also an epsilon symbol. For first of T, we go to F first of F. For first of F is the open brace or A. So we copy both those things in first of T. First of H is star or epsilon. We add both those things to first of H. For F, it will remain the same, open braces or A. So in this way, we have found the first set of the given production. To find follow of the given set, we start off with G. So since the starting thing, we always had dollar at the start of it. So follow of G is follow of E. So follow of E is the closing brace. Hence we have dollar and the closing brace up here. Follow of E. Follow of E. We see the whole thing where E appears. E appears in only G. So follow of E will be follow of G. Hence we copy from G. Follow of K. We search the whole production to find where K appears. K appears in E. Hence we see that follow of K is follow of E. So we copy it from E and place it in K. That is dollar and the closing brace. Follow of T. We traverse the whole production to find where T appears. T appears in E and K. So from E we see that follow of T is dollar and the closing brace. So here it is TK. Hence we have to find the first of K to find the follow of T. First of K is plus and epsilon. So we add the plus first, and when we put epsilon in place of K, we see that follow of K happens to be follow of E. So we copy the whole thing from E. So now we have plus dollar and closing brace. Follow of H. We find the whole thing to see where H appears. H appears in two phases, T and H. From T, we see that follow of H is follow of T. We copy the same thing from H, T into H. Finding the follow of F. Follow of F. So we traverse the whole thing to find where F appears. F appears in T and H. From T, we see that follow of F is first of H. So we add the first of H datas and find follow happens to be star and epsilon. So instead of epsilon, we substitute epsilon in place of F and C. From that, we get plus dollar and the closing brace.
Let us understand the parsing table of LL1 parser. Before understanding the parsing table, let us understand what are parsers. Parser passes the unambiguous grammar and it does not make use of ambiguous grammar. But there is an exception of operator precedent parser that passes the ambiguous grammar. Parsers are divided into two parts, top-down parsers and bottom-up parsers. Top-down parsers are based on leftmost derivation, whereas bottom-up parsers are based on reverse rightmost derivation. LL1 parser belong to top-down parsers. The process of constructing the parser tree, which starts from the root and goes down to the leaf, is top-down parser. Top-down parser construct grammar which is free from ambiguity and left grammar. Top-down parser is further divided into two parts, top-down parser with backtracking and without backtracking, and is further subdivided into brute force technique and recursive descent parser. Let us look at the brute force technique. A non-terminal, go with the first alternative and compare with the given input string. If the matching does not occur, then go with the second alternative and compare the given input string. Go with this matching unless the matching occurs for one alternative. If matching occurs, then the input string is parsed properly. This is the brute force technique. Let us understand the recursive descent parser technique, which is also called as predictive parsing. LL1 parser is constructed from grammar which follows the ref recursion and ambiguity. LL1 parser depends on one look ahead symbol that predict the prediction to choose what to use when we have alternative. This is the recursive descent parser technique. Now let us take this grammar as an example for making of parsing table. Before generating the parsing table, these are some of the steps that will help us for making of parsing table. The first step is to create the first and follow table. First and follow is explained in the earlier slides. Let us consider for every production A gives alpha. Alpha can derive a string starting with A, that is for A in first of alpha. If alpha derives an epsilon string, then for all B follow A string that is derived from A. Now let us look at the output. The variables are going to be the rows such as G, E, K, T, H, F, and the terminals are going to be columns such as plus, A, opening bracket, closing bracket, etc. If I am saving at G in derivation process and want to derive a symbol A, then it depends on if the production contained that symbol or not. Look at the grammar. G derives E dollar, and from the first and follow table, look at the first of E, that is A and opening bracket. So under this we will write G derives E dollar. Now look at the grammar that K derives plus TK, and from the first and follow table look for the first of K, that is plus. So under this we will write K derives plus of Tk, and also K derives epsilon. So under such cases we have to look at the follow of K from the follow table, that is closing bracket and dollar. So under this we will write K derives epsilon. So in this way we are going to fill the parsing table. Now these are some important points. Every grammar is not feasible for LL1 parser. It can be possible that a cell can have more than one production.
Hi, this is Heeral and I will be explaining the algorithm followed by the LL1 parser. The three important components which are connected to the LL1 parser are the stack, the input buffer, and the parsing table. Now for the algorithm, the stack is initially empty and it contains only the starting symbol and the dollar symbol which denotes the top of the stack. The algorithm has three basic rules. So the first rule is, if the top of the stack is a non-terminal, we replace the top of the stack with one of the productions of the non-terminal, and we select the production by checking the next K input symbols without actually moving the input cursor. The second rule says that if the top of the stack is a terminal, then we read the next input token. If it is the same terminal, then we pop the stack and we continue. Otherwise, the parse has failed and the algorithm finishes. The third and final rule of the algorithm says that if the stack is empty after going through the entire input sequence, the parse has succeeded and the algorithm finishes. We make an assumption that at the end of every input string there is a dollar symbol which denotes the end of the string. So this is the LL1 parsing algorithm in the pseudocode format. The stack is initialized with S and the dollar symbol, and we repeat the first two rules of the non-terminal and terminal until we reach the dollar symbol, which is the end of the input string. Note that X over here denotes a non-terminal and T denotes the terminal. Now let us see how we implemented the LL1 parser in Java. The link to the code is given in the description below. So let me explain the code that we have written in Java to implement the LL1 parser. From Java utils we have imported the stack and the scanner. This is the grammar that we have used for this LL1 parser, and the construction of the first and follow and the parsing table for this grammar is explained earlier in the video. So now this LL1 parser is the main class which is given the inputs of the terminals and the non-terminals and the parsing table. So we have a function called push rule which pushes the rule to the table. After that we have the algorithm. The algorithm follows the procedure that was discussed earlier. So we check if the input string is a non-terminal, and if it is, then we have to push the rule to the stack, and if it is a terminal and if it is not equal, there is an error, and if it is, then we read it, that is we accept the terminal, and if none of the cases match, then it is an error. If the dollar symbol is identified from the input string, it denotes that the expression is come to an end, so we come out of the algorithm loop. And finally, if it is accepted, we print that the input is accepted by the LL1 parser. And if it is not, then we say that the input is not accepted by the LL1 parser. We have other functions as well, which is terminal and is non-terminal, which actually checks if the input character is a terminal or a non-terminal symbol. We have read, which reads the next character of the input string, and the push and pop functions to implement the stack. Apart from which, we have an error function and a get rule function. Error function just displays the error, and the get rule function is used to get the production rule of the particular non-terminal. We also have get non-terminal index and get terminal index functions. After which is the main driver function, which is used to take the input string from the user and send it to the LL1 parser. So let's just run this program on a terminal. So we first compile it. So now let us run the program and give a few input expressions and see if it is accepted by the LL1 parser or not. So as you can see, for a valid input, the LL1 parser accepts it. And for an invalid input, it does not accept it. Thus, we have completed the execution and implementation of the LL1 parser in Java. Thank you.